Good morning, students. So this is our first class in system software. So in our system software class, in our system software subject, we have categorized our subject into 5 units. So in our first unit, we are going to see about the different kinds of architectures. And in the second unit, we are going to concentrate on assemblers, which is a type of system software. And in the third unit, we are going to see about the linkers and loaders. And in the fourth unit, we are going to see about macroprocessors. And in the fifth unit, we are going to see about other different kinds of system software tools available. So first, in our first unit, introduction, system software. So first, what is meant by a software? As we all know that software is a generic term. It is nothing but a collection of data and computer instructions. So we are categorizing our software into two types. One is system software and the other one is application software. So application software. What is meant by application software? Application software is nothing but it helps us to provide the user's task. It performs user specific tasks. The best example for our application software is a word processor. And whatever the softwares we are using nowadays, all comes under application software. Then system software. System software coordinates the activities and functions of hardware and software and controls the operations of computer hardware. Coordinates the Example of our system software is our operating system. So operating system, it controls the computer hardware and acts as an interface between our application software and the computer hardware. Second example for system software is our language processors. So language processors helps us to convert the user instruction to machine understandable form. Usually the user instructions are categorized into three types. First is machine level language. Second, assembly level language. And third one is high level language. So machine level language is the string of zeros and ones which are understandable by our machines. Assembly language is a combination of mnemonics, and high level language, it uses English like statements and it is completely independent of the machines. Whatever programs that are written by the users are called as source code, and the set of instructions that is understandable by the machines is called as object code. So our language interpreters helps in converting this source code to object code. Our language interpreters are categorized into three types. Assemblers. So assemblers helps in converting our assembly level language into machine level language. Then interpreter. Interpreter helps in converting our high level language to machine level language, but the type of conversion is line by line. Then compilers. Compilers helps in compilers also do the same process what interpreter will do. It will also helps in converting the high level language to low level language, but the type of conversion is as a whole, not line by line. Other kind of system software is, other than operating system and language processors, other kinds are utility software. So utility software manage, maintain and control computer resources. Example for utility software is our antivirus software. Then antivirus software. What is antivirus software? Antivirus software helps to protect our computer from viruses and other harmful programs. Then other utility softwares are backup software. So backup software helps in creating the backup of the files in our computer. Then another kind of system software is device driver software. So device driver software is nothing but it is a computer program that controls a particular device that is connected to a computer. So what are the external devices? All computers will have many external devices like keyboard, mouse, printer, projector. Many external devices will be connected to our computer system. So each of these devices need a driver in order to work properly. This device driver software also acts as a translator between the operating system and the hardware devices connected to it. For many of the devices, all the necessary driver softwares will be built in our operating system. If the driver software is not available in the OS system, we will be downloading from the internet and we will use a device driver software for the proper working of these devices. Another kind of system software is firmware. So firmware is also a software program permanently etched into a hardware device. It is programmed to give permanent instructions to communicate with other devices and perform functions like basic input and output tasks for the devices. The best example of a firmware software is our TV remote. So in our TV remote, a particular software will be permanently etched into the TV remote. So this software helps in the communication of the signals from the TV remote to the TV. So these are the necessary system softwares that is available. Apart from this, more number of system softwares are also available. Next, we are going to see about the important features of our system software. First feature, as we all know that system software is a machine understandable software. So this system software will be written in low level language. Since it is written in low level language, it is very closeness, it provides a closeness to the system. Since it is very closer to the system, it works faster. So the speed of our system software is very fast. Since it is written in low level language, it is difficult to design and it also difficult to manipulate. So these are the various features of system software. As we have seen before, application software is the software that is built to perform user-specific tasks, whereas system software is a software that is built to perform system-related functions. Now, let us see some of the difference between system software and application software. So, system software, the first difference is system software will perform system related functions, whereas application softwares will perform user specific task. Then our application software, since it performs user specific task, it is a specific purpose software. And our system software is performing system related functions, so it is a general purpose software. So system software is very closer to the system. So system software will create its own environment to run itself and to run other applications. Whereas application software is dependent on system software, so it performs in an environment created by our system or by our operating system. Our system software is performing system related functions, so it executes all time. Whereas our application software will execute as and when required. If a user requires to operate in a word processor, he will open it and use it. If he likes to play a video or to hear a music, he opens the specific software and use it. So an application software will execute as and when required, whereas a system software will execute all the time. System software, without system software, many of the functions will not work. So system software is very much essential for a system, whereas application software is not as much essential. Without application software also, we can use a system. The number of application softwares created is more when compared to system software, where the number is less for system software. So these are the major differences between system software and application software. Now let us see an example of how we are writing a C program and how this is executed and what are the system softwares related for the execution of a C program. So first what we will do, we will write a C program. Where we write it, we will be using a IDE to write it. So that is a text editor will be used to write a C program. So the text editor is a system software. So after writing the computer program, what we will do? We will compile it. So the compiler is a system software. As we have seen before, compiler is a type of language processor. It helps in converting our high level instructions into machine level instructions as a whole. So compiler will translate the machine our high level language program into machine level language. So while compiling, linker, it is a special type of system software. It helps us to link the function and resources whatever needed for a program to execute. So link loader. After linking, loader ensures all necessary programs and libraries are loaded, which is executed during the startup phase of running a program. Then the next system software is debugger. So debugger is nothing but it is a system software used to test and find the errors present in our program. So these are the various system softwares that are involved while executing a particular C program. Apart from this, many system softwares are there depending upon our high level language program, but the basic system softwares are these 5 types. So that's all about the basic introduction of our system software. Now let us start our unit 1. So in our unit 1, the first topic is SIC. Different computers have different features. So different computers will be manufactured by different companies. So different features means there are a lot of features available in computers that are manufactured by different companies. So studying all the features one by one is a tedious process. To avoid this problem, we are going to study a simplified instructional computer, SIC. SIC stands for Simplified Instructional Computer. It is nothing but it is a hypothetical computer. Hypothetical instance, it is a sample computer which has been designed to include hardware features most often found in many computers. SIC is a idosynchronis of different features in different machines. In SIC, we are having 2 versions. Standard model and XE model. XE stands for extra equipment. Extra equipment, XE. So now we are going to see our SIC and the various features, the basic hardware features available in SIC. So we are going to see about 7 different features. One is memory, registers, data formats, instruction formats, addressing modes, instruction set, and input and output. So these are the hardware features that we are going to see in all our architectures. First we will be seeing about SIC, then we will be seeing about SIC XE, then we will be seeing about CISC, complex instructional set computers, then we will be seeing about RISC, reduced instructional set computers. So all these 7 features we are going to see in all these architectures. So first, memory in SIC. Memory. So the memory in SIC is 8-bit bytes. 8-bit bytes means it is 1 byte. So all 3 consecutive bytes will form a word. Bytes form a word. So a word is equal to 3 consecutive bytes, that is 3 byte. That is equal to 3 into 8 bits, that is equal to 24 bits. So a word in SIC is of 24 bits. So all addresses are byte addresses. Words are addressed by location of their lowest byte. For example, if memory starts from 0, it is from 0 to 4 or 0 to 2 or 0 to 6. If memory starts from 4, it is from 4 to 8, 4 to 6 likewise. So totally we are having 2 power 15 memory, that is equal to 32,768 bytes or 32 KB memory. So this is about memory. So next is registers. So what is mean by register? Register is one of a small set of data holding places which is a part of computer processor. It may hold instructions, storage address or any kind of data. So in our SIC there are about 5 registers. First register is accumulator. So accumulator is meant for performing arithmetic operations. Then X stands for index register and it is used for addressing of our instructions. Then L is our linkage register. So linkage register is used to store the return addresses of various instructions like JSEP and RSEP. JSEP is jump to a subroutine, RSEP is return to a subroutine. While jumping to a subroutine, the linkage register helps in storing the address where this particular jump has to be performed, and while return RSEP also, return to subroutine also, linkage register will help to store the address where after jumping the particular instruction has to be returned. PC is our program counter. So program counter will contains the address of the next executable instruction. Then the last register is SW. SW is status word. So status word register, it will maintain the current status of the system. Also it will contains informations like condition code, CZ. See, condition code is nothing but a code generated when a condition is used. For example, if a condition holds true, some value will be stored in the condition code, and if a condition holds false, some value will be stored inside the condition code. Like we are setting flag value. We will be setting flag value if a condition holds true. Flag is equal to 1 if a condition holds true, or if a condition holds false, we will be storing flag is equal to 0. So that is the purpose of condition code. So status word will contain the informations like condition code also. So that's all about registers. Now next hardware feature is, as we seen before, data formats. So data formats, usually what are the different types of data types we have? Integers, characters, float values. So in our SIC machine, integer are stored as 3 byte. That is 24-bit binary number. Then character are stored as 1 byte, that is 8 bits ASCII code. And negative values, for negative values 2's complement method is used. Hope you know the 2's complement method. 2's complement method is nothing but 1's complement plus 1. 1's complement is, if it is a 0, it has to be converted to 1. So likewise, if it is 0, 0, 1, 0, we will be converting like 1, 1, 0, 0. This is 1's complement. And if we add a 1 to the 1's complement result, it is our 2's complement. So 2's complement method is used for storing our negative values. And in our SIZ, we are not having any floating point hardware. No floating point hardware. So floating point operations cannot be performed in SIZ. Next hardware feature is instruction format. Instruction format defines the layout of the bits of instruction in terms of constituent parts. So it defines the layout. So the layout used in SIZ is opcode, X and address. So this is our instruction layout. Opcode is 8 bits, X is 1 bit and address is 15 bits. So totally our instruction format for SIZ is 24 bits. So all SIZ will have 24 bits format, and X is for index addressing. This is the instruction format. Next, addressing mode. Two addressing modes are there in our SIZ machine. So this addressing mode is indicated by the setting up of the X value. So the two addressing modes are direct addressing mode and indirect addressing mode. So in direct addressing mode, our X value will be 0, and in indirect addressing mode, our X value will be equal to 1. If the X value is 0, it is direct addressing, and if the X value is 1, it is indexed addressing. The target address for direct addressing is the address that have been mentioned in the address field itself. And for indirect addressing, the target address is calculated by the address that have been mentioned in address field plus the value that is stored inside the index register. Now let us see example for both direct addressing and indirect addressing. LDA 10. Okay. So for each and every mnemonic, we'll be having an opcode. In our system software, we are going to completely deal with assembly level language only. So every instruction will be in the form of assembly language. Assembly language is a combination of mnemonics. So the opcode for LDA is 00, and 10 is nothing but it is a label or variable. It is stored in the address 1000. So what is our instruction layout? Opcode, X and address. I have this is an example for direct addressing. So how will be our opcode? So opcode is nothing but the opcode for our mnemonic LDA. LDA is load into the accumulator. What is the opcode? 00. So you have to write it in 8 bits. 00000000. So this is our opcode. And the value of X is 0 because it is an example for direct addressing. Then 10. The address where 10 is stored is 1000. So it has to be represented in 15 bits. 0000 000008 0000 then 100 1000. 15 bits, 1 bit, 8 bit. So this is the instruction layout for this particular instruction. This instruction will comes under direct addressing mode. So how we will calculate the target address? Target address is equal to the address itself. So what is the address that have been mentioned in our address field? What is the address? This is our address 1000. So the target address is equal to 1000. This is an example for direct addressing. Next, example for indirect addressing. STCH buffer comma X. So the opcode for STCH is 54 comma X. Always indirect addressing or indexed addressing will be mentioned like this, comma X. X stands for index register. So indirect addressing will always mentioned by the instruction with a suffix value of comma X. Now let us write this instruction in our instruction layout. So opcode is 54, you have to write it in 8 bits. 5 is 0101 and 4 is 0100. Since it is comma X means indirect register or index register. So the value of X for indirect register is 1. Then buffer. So let us assume that buffer is also a label. It is also stored in the address 1000. So how you will represent the address field? 1000. It has to be represented in 15 bits. 0000 000008 0000 12 0 100. So totally 15 bits. So how you will calculate the target address for indirect addressing? Target address is equal to address plus value that is stored inside the index register. So what is our address? 1000 is our address plus the value that is stored in the index register will provide us our target address. Next, instruction set. So this is the next hardware feature. Instruction set provides basic set of instructions which is sufficient for performing simple tasks. The instructions that are used in our SIC architecture are load and store operators. Load and store registers, that is LDA, LDX, STA, STX. Then integer arithmetic operations is only available in our SIC, since our SIC will not support floating point operation because no specialized floating point hardware is available. Integer arithmetic operations will be performed. So the instructions for performing arithmetic operations are add, add for performing addition operation, sub for performing subtraction operation, and mul for performing multiplication operation, and div for performing division operation. Next, COMP instruction, that is compare instruction. So this compare instruction will compare the value in register A with the word in memory. After comparison, it sets the condition code CC. As I told before, condition code will help to store the result of the condition. Next is jump instruction, conditional jump instructions. Conditional jump instructions like jump JLT, jump less than or equal to JEQ, jump equal to JGT, jump greater than or equal to. It also will test the value that is stored inside the condition code, and according to the value it jump to the specific location. Another kind of instruction is subroutine linkage. So in subroutine linkage, we are having two types, J sub and R sub. So J sub will jumps to a subroutine placing the return address in register L, and R sub will returns by jumping to the address contained in register L. So next hardware feature is last hardware feature that we are going to see in our SIC is input output. Input output is performed by transferring one byte at a time from the 2 or from the rightmost 8 bits of register A. Each device for performing the IO will be performing IO with the devices, input and output devices. So each devices will assigned with the unique 8-bit code. There are 3 IO instructions for performing the input and output. So these IO instructions are specified by device code. So this device code will act as an operand for these instructions. So each and every device is associated with IO will be having a unique 8-bit code. So the first IO instruction is TD instruction. TD is test device instruction. So it tests whether an addressed device is ready to send or receive. So after testing, after every condition checking, we will be storing the result in a condition code. So the condition code CZ will contains the result of whether the device is ready to sending or to performing IO. So if the device is ready, the value stored will be less than symbol. The device is ready to send. If the device is not ready, a value equal to will be stored in condition code. Second type of IO instruction is RD. RD is read data. Once the device is ready, RD instruction is used to read the data. Third IO instruction is WD. WD is write data. So it helps to write the output to a specified output device. So that's all about our SIC machine architecture. So we have seen the 7 hardware features in SIC memory architecture. Thank you.